Welcome. This video covers how to create histograms, density plots, and box plots in SAS. We're going to try to describe the distribution of a numeric variable in this video. Remember, the numeric variables are variables whose entries are numbers, and you can do math on them. When we talk about describing the distribution, we're trying to describe the pattern and frequency with which we observe that variable. And we can describe the distribution pretty well using a histogram. That's going to allow us to look at the shape of the distribution. And then a box plot is going to do a nice job summarizing a number of the key attributes of the distribution as well. So we'll look at both of those. We'll start with histograms. So histograms just take your continuous or numeric data. It doesn't have to be continuous, but your numeric data, and it puts it at the groups. It groups them into bins, and then just reports the number within each one of those bins. And this is a nice way to look at the distribution, again, the shape of that distribution of that numeric variable. We're going to look at this CO2 data set that we looked at previously. And remember that our response variable, the one that we cared the most about for this study, was that uptake variable. And that's what we're going to focus on here. Well, if I want to create a histogram in SAS, well, we talked about using this PROC SGPLOT procedure to create our graphs. And we're going to use the same procedure here. All we need to do is change the statement that requests the type of plot. And so we're going to use the histogram statement, and we just specify the variable we want the histogram for. And so you can see over here on the right a histogram of this uptake variable. Okay, so this gives us some idea about sort of the pattern that we see in this data set. It's useful. We can, of course, customize this quite a bit. We saw this page in the previous video that gave us a number of the commonly changed attributes for plots. And so if you go in there and you play around, you can see that you can change the fill attributes just like we did before. And just like we did on the bar plot, we can add a data label. So we'll add those two things, and now we see a little bit different looking plot that maybe we like a little bit better. We can also do things like overlay plots. So in this case, we're going to create a histogram, that same one we just did before, but then we're going to overlay a vertical line on top of that. And so we're going to overlay a vertical line corresponding to the sample mean of the data. And we had to calculate this, in this case, calculate this from one of our other procedures and then put it in manually. But what we're doing here is we're saying add a reference line at this value, 27.21, and do it on the x-axis. So that's going to make it a vertical line. And then we're going to use the line attributes option to change the pattern and thickness of that line. Now you do need to be careful with overlaying plots. If I put the reference line first, that's going to be different than if I put the histogram first. So histogram coming first, and then reference line coming second. That overlays the reference line on top of that graph that we just created. And so now this tells us exactly where the mean occurs in this histogram. We can also change again more of the options and also add groups here so that we can see, remember that we had a couple categorical variables, so maybe we want to see the distributions across those two groups. So we're going to add a group equal treatment option. And then anytime you do the grouping, you probably want to do some transparency just to sort of make it look a little bit nicer. And we'll also add a data label on top so that we can see how many are in each group. And so this is a little bit hard to see, but you can see that there are data labels on top of each of these. And if we hadn't put the transparency in there, it would be a little bit harder to see as well. Now, histograms are great, but they do have a little bit of a problem. And that problem is that if you don't have a large sample size, histograms can be pretty variable based off of the bin width that you choose. And so one way to sort of get around that is to create what's called a density plot. And so a density plot allows you to have a smooth density that you fit to your data instead of the sort of rigid histogram that can change based off of where you put your bins. And what's nice about PROC SGPLOT is you can actually overlay the two types as well. And so here I'm going to do a histogram statement first. So that'll be the plot that's on the bottom. And then we're going to put a density plot on top. And its density plot by default just fits a normal curve, so it takes the best fitting normal curve for the data and plots that on top. And I'm using group equal treatment in both of these, and so it's going to create two normal distributions corresponding to each one of those treatment groups. And so here you can see those overlaid on top of our histogram. And clearly this normal distribution business isn't quite fitting the data very well, right? There's this big gap here in the middle for the red group, and so that this just is not really doing a great job fitting for us. So we probably don't want to use a normal distribution if we're trying to do a smoothed approximation. And so what we can do instead is use a kernel smoother. So a kernel smoother just puts a certain weight on each point, and then as you draw your plot, it just adds up the weights across the different points. So for instance here, there's a point at 2, and a normal distribution is associated with that. There's a point over here at just below -1, and another point here just above -1, and each one of those has a normal distribution associated with it. And the height of the actual curve that we're going to draw is then just the sum of all the normal distributions that appear there. And so you can use different bandwidths to say how wide these normal distributions should be, and you can use other weighting functions as well. But by default, this is roughly what SAS is doing. And what this does is it just makes a nicer looking smoothed plot. And so to get this kernel smoother, we just change the type equal option to type equal kernel on the density statement. And now we can see nicer looking approximations to our distributions. We see that where it dropped down over here, our curve slightly goes down and then kind of stays up because there's one bar that has a little bit more in it and then goes down the rest of the way. So these are much better approximations and generally better than histograms to use when you have small small sample sizes. All right, we also talked about doing multiple graphs of the same type across the categorical variable. And so remember, basically whatever you do in PROC SGPLOT, if you want to do that same plot over and over again, you can just take that code, bring it into PROC SGPANEL, and specify a panel by variable to get that same plot over and over again. And what we're going to do here is we're going to panel by that treatment variable instead of having that in my plots. And I'm going to do a histogram of uptake and a density plot of uptake overlaid. And so this gives us a little bit different view of that same exact relationship we saw on the previous page. Personally, I think that this is a little bit clearer because it's a little bit hard to tell what's going on with these overlaid plots. So that looks pretty good. All right, aside from the histogram and the density plots, which allow you to get a really good idea about the shape of the distribution that you're looking at, a box plot is great for summarizing your distribution overall. And really what it does is it just takes some of those summary statistics that we looked at previously and it puts them into graphical form. And a box plot really is just going to plot the 5-number summary. And the 5 numbers it plots are the smallest value, the largest value, the first and third quartile, and then the median. Remember, the median is the value that has 50% above and below it. First quartile is the 0.25 quantile or the 25th percentile. That has 25% of the data below it, 75% above it. So, one other thing that these box plots often do, which is really nice, is they will identify possible outliers. So these might be points that you might want to inspect a little bit further to see if there was some data entry problems or something else where you might want to exclude those observations. How we do this, we're going to use the PROC SGPLOT procedures just like we did, but now we're going to use VBox or HBox to create either a horizontal box plot or a vertical box plot. Just like we saw with the bar plots, we're going to be able to use an option that now allows us to have multiple ones of these for different categorical variables. So we'll have a category equal option here. So here's an example of creating a box plot for the uptake variable at every level of the treatment variable. We have 2 values here, chilled and non-chilled. Now you can see the 5-number summary produced here. And this gives us a really nice way to compare 2 distributions and where they're located. SAS actually also adds in another value by a line. This line is the median, but it also adds another value here, this diamond. This represents the mean. So you can also see the sample means and compare them through this box plot as well. One other thing you might want to do, and this is especially true when you have lots of data points, not as needed when you have less data points, but you can add in the points on top of your box plots if you want, so you can get a better idea of the actual shape of the distribution. And you can do that by adding a scatter statement and using a jitter option on that. Again, we're going to overlay these 2 things. So we're going to do the box plot first, so that's on the bottom. And then we're going to overlay the scatter statement on top, so we're going to put the points on top. And we're just going to specify that the x variable should be treatment, because that's what our categories are, so that's what's going across the x-axis. And then our y values, we want to have the uptake variables themselves. Now, if we didn't add this jitter bit, the points might, if we had 2 points in the same spot, they would lay right on top of each other, and we wouldn't be able to see that there's 2 points there. It would just look like 1 point. By adding jitter, it just moves those points a little bit horizontally back and forth so that you can then see the different points. So for instance, in this little chunk here, we can see that there are multiple points there, but they've been jittered a little bit so that you can at least see that there's a couple. And this jittering is just done randomly. Again, if you had lots and lots of data, this could be really useful, but even here it's a little bit useful. You can see that there's a decent number of points up here in this tail. So that's kind of interesting, and there's not that many here in the middle. So this does give us some extra information. Just like before, if I wanted to have multiple box plots across another variable, I could use a panel by. So here I'm going to panel by type in my PROC SGPANEL, and then do that same exact plot that we just did. And now I get for my treatment groups chilled, non-chilled, but at type equal Mississippi. And then the same thing for type equal Quebec. That was one of these other categorical variables we had in our data set. So hopefully you're seeing how cool it is, this SGPANEL and SGPLOT procedures, how they work together, and how flexible they are for creating really customizable graphs. Let's jump into SAS and do a couple examples. Here we are in SAS, ready to create some plots. We'll again stick with this news data set, this online news data set, and we'll go ahead and create a histogram. Remember that the main numeric variable of this news data set that we cared about was the shares, representing the number of times that the articles were shared. So what we can do is PROC SGPLOT. We can specify this data set, of course. And then if we want to, the most basic kind of plot you make is the histogram, because this gives you a good idea about the shape of the distribution. And I don't remember if we need to, yeah, we do have to do the special share, special way of specifying this variable name. So we'll do shares, and we'll just look at what that histogram looks like to start with. So we run that, log looks fine, but we can see that there must be some value way out here. Most of these articles have shares that are small, and then there must be a couple that are really far out here. And we saw this in our data when we were looking at the numeric summaries. We had a median that was much lower than our mean. And so if we just want to sort of look at where the bulk of the data is, we could specify a cutoff using a where statement and say where my shares are less than, let's say, 10,000. Let's go ahead and do that. And now we can look at how the bulk of the articles look in terms of their distribution of shares. Okay. So now we're seeing a nice right skewed distribution. So there must be that there are some articles that are just shared much, much more than most of the articles in this data set. So maybe we don't want to stop at 10,000. There still seems to be a reasonable percentage out here. Let's go ahead and up that to maybe 20,000. But what we can do is sort of up this plot a little bit. Maybe we want to add in that density plot, overlay that. So we'll do a density plot for shares as well. And we'll do that type equal kernel, because clearly this is not a normal distribution. Let's see what that looks like. Okay, great. So we have a lot of data here, so the histogram is going to do a good job approximating the shape of this distribution. We see that this smooth density plot looks pretty much the same as the histogram. That's good. It's good to see. Now, let's go ahead and switch this over to PROC SGPANEL, and let's panel by some variables to break this up and look at it. So I'm going to copy the exact same code, but now I'm going to switch SGPLOT to SGPANEL, and we just need to add a panel by statement. So we're going to panel by, we created that variable called type, so we can panel by type and have an idea of the distribution of shares across business articles, entertainment articles, etc., etc. So let's run this. Should always check our log. I haven't been doing that. I apologize. So everything looks good. There's some notes here to help us out, but that's fine. So here's the results. We can see the distribution of the shares across our 6 different types. So again, this is really super useful for visualizing our data and our distributions. Looks like all the distributions are of roughly the same shape, although perhaps there are a higher percentage here of the entertainment articles that have less shares, something like that. All right, fantastic. We can now create all sorts of graphs, especially now graphs associated with one numeric variable. What we'll do in the next video is look at what we can do with 2 numeric variables and visualizing that linear relationship through scatter plots.